So we're moving into a section of our course where we're going to deal with angles that we know how many degrees they make them up. So we're moving away from Pythagorean theorem, although Pythagorean's theorem is still going to apply in this section. Now, I did spend a little longer with Pythagorean theorem than I might usually do, but I've discovered that's one of the pieces that people forget how to take and apply in a trade context. So if you're wondering why were the questions all like use Pythagorean theorem once or twice and then use it to find other information, it's because that's what we do in the real world. That's the important part of using math in everyday work in the trades. Things aren't isolated. Things actually come together, use multiple components together. So in the last section, we used area a lot with Pythagorean theorem in order to calculate siding and roof quantities, something that is done very commonly as a carpenter. Now we're moving into a section where we're going to deal with angles. Angles you're not maybe going to use as much at the beginning. Angles are used when you're figuring out stairs. And angles are also used if you're doing a little bit of surveying. So I was talking to one of the carpentry instructors, where do you use SOHCAHTOA? So you'll know what I mean. If you don't know what I mean when I say SOHCAHTOA, you'll know what I mean by the end of this lesson. And he says, well, we don't really use it much other than doing site layouts and stairs. So we're going to just work through this section quite briefly. It's really fairly simple. And we're going to use rafters kind of as our key piece when we get to doing some application, but I'm also going to give you a little bit of site layout. So using trigonometry to figure out, well, how deep is a basement? Do we have our hole dug deep enough? By how much is the elevation of the land out and that kind of thing. So we'll do a few surveying kind of based questions, but oftentimes you would bring somebody in specialized rather than doing that yourself. It is good to understand how and where the numbers come from. So again, we're dealing with right triangles, and there's a few things that you need to know, or terms that you need to know. So we've looked at this before. Turn on here we go. Sync my tablet with the computer. All right, so we've looked at this picture before when we dealt with Pythagorean theorem. So we have our right angle here in the corner, and across from that we have our side that's a hypotenuse. Now, when we deal with right angle trigonometry, so we're going to deal with the sine, cosine, and tangent of angles, we will label the other sides of the triangle not using A and B, but we're going to call this side, it's opposite of the angle, so we're going to call it opposite. Not rocket science. And then this one we will call the adjacent. Adjacent just means next to. It's next to the angle. So you will see O, H, and A as abbreviations for opposite, hypotenuse, and adjacent. Okay, those are our important labels. Another important piece of information to make note of, something that I'm going to guess a lot of you know already, but you might have forgotten about it. The sum of all angles in a triangle is equal to 180 degrees. So that's something to keep in mind, and it'll come in handy for solving triangles. All right, so there are 3 trig functions that we're going to deal with in right angle trigonometry. The 3 functions are labeled here, and I've got them labeled in their technical names, the abbreviations we use in our calculator, and then the abbreviation we use to remember the ratio. So the sine ratio, it's not a sin ratio because there's actually an E on the end of it. We abbreviate that in our calculator as SIN, sine. And it is the relationship between the hypotenuse and the opposite side of a triangle. So what the sine ratio says, if we take the sine of an angle, it will always be equal to the ratio of the opposite side divided by the hypotenuse every single time. Now, how does that line up here? The S is for sine, O is for what goes on the top of the fraction, and H is for what goes on the bottom of the fraction. So these two are our ratio pieces, top and bottom. So it doesn't matter, anytime we have the ratio of opposite and hypotenuse being the same, we know that that triangle will share an angle with another triangle that has the same ratio. Okay. Then we have our cosine ratio. The cosine ratio is abbreviated cos in your calculator, and it's CAH. Well, what do you think that is? C is cosine, A is for adjacent, so that's our adjacent side here, and again, we have our hypotenuse. So the cosine of an angle is the ratio of the adjacent side divided by the hypotenuse. Lastly, there's two other sides we haven't compared, is the tangent ratio. It's abbreviated as tan, and TOA, T-O-A, tan of an angle, throw the angle in here too, is equal to, O is first, so opposite on top, over hypotenuse, oops, not over hypotenuse, over adjacent. So we have opposite and adjacent. So we're comparing all the different sides of our triangles to get our ratio. Now we use the acronym SOHCAHTOA, these little abbreviations to help us remember what the ratios are. Now, depending on where you've gone to school, you may have heard some other ones. Three Oaks, if you had Ms. Clow there, one of her favorites is to use old houses always have old attics. So you'll notice we're just putting the ratios and we're just leaving out the sine, cosine, and tangent. And old houses, that goes with sine, always have goes with cosine, and old attics goes with tan. In your calculator, they're always in the order sine, cosine, tangent. So the order is easy to remember. The most memorable way to learn these came from Kensington High School. I don't know if any of you guys are there, and I kind of did a double take the first time I heard it. It was some old hippie caught another hippie tripping on acid. That one stuck. I'm not sure if it was necessarily appropriate, but that one stuck. So whatever it takes for you to remember those ratios. Now, you will not use these ratios on your block exam, so you don't have to worry about committing a whole lot of your memory to memorizing them, but you will definitely see them come up again in your second block. So we're just preparing you for that now. All right. So let's do a quick calculator check. There are two types of calculators you could have, and this is one of the things that always takes the longest in class, is to make sure everybody can use their calculator properly. Now, I'm not going to give you instructions for a phone. If you're using your phone, it's up to you, but I will give you the instructions for this is the block calculator. And this is my favorite calculator, but most scientific calculators are quite similar. So we have a one-line calculator, and you'll see this one has two lines in the calculator. So there's two different calculators. When we're using trig functions, if you're going to be using sine, cosine, and tangent, or if you're going to be using angles, one of the first things we need to do is we need to check our calculator to see if it's in degrees. In this calculator, up at the top, you'll see it says DEG. Sometimes it will just have a D, and I'm looking for this one right here. This second calculator, there is a D right up there. So that means we're in degree mode. There's degrees, radians, and gradients, three ways to deal with angles, and we're going to use degrees. Okay, so once you've identified that it's in degrees, if you're not sure whether it's in degrees, you need help putting it in degrees, turn your calculator on, take a picture, send it to me, and I can figure out how to switch it for you. All right, so now we need to be able to calculate. So we need to be able to find the ratio of sides that gives us a sine of 45 degrees. So we want to find the decimal that would be equal to 45 degrees. So in order to do that in your calculator, there's two ways. This block calculator, I'm going to deal with that one first. This is what I often call a backwards calculator. In this calculator, you are going to go 45, and then you're going to press sine. And then you'll do equals. Okay, So you number first. I say backwards because you put the number and then you're going to put sign. It's my reasoning for calling it backwards. So if you have that calculator, this is not where I want to be. There we go. If you have that calculator, you should get sine of 45 is equal to 0.7071. Okay, so do a check. This calculator is what I call a frontwards calculator. If you have this calculator, usually you're somebody who's used it a fair bit. In this calculator, you would press the sign button first, and then you're going to type in 45, and then you're going to press equals. Okay, and the nice thing about this one is it will tell you right on the top what you've put in last. But for the block exam, they always give you this particular calculator. There's a white version of this as well. You may happen to have the white version. I've got an older gray one. All right. So do a quick check. Make sure you can put them in. Cosine of 35 should be 0.8192. And tan of 80 should be 5.6713. So this is just sine, we learned already, is equal to the ratio of opposite divided by hypotenuse. So if you take the length of the opposite side and divide it by the length of hypotenuse, you will get 0.7071 if the angle is a 45-degree angle. This one would be equal to the ratio of adjacent and hypotenuse, and this one is equal to the ratio of opposite over adjacent. Okay. Now, one thing to note, I have evaluate the ratios given the angle round to 4 decimal places. Anytime you're putting sine 45 or the cosine of an angle, when you want to find the ratio, always keep 4 decimal places. If you don't keep extra decimals, it's going to really mess your answers up, and it could cause a little bit of trouble when you're dealing with questions in exam. Now we need to check the other one. So we need to figure out, well, if we know what the ratio is, what's the angle that would make that ratio true? So how do we put that in our calculator? To do that, we want to undo sine. And in order to do that, we are going to find our angle, we want to take the inverse sine, so sine minus 1 of 0.5. On your calculator, you're going to press shift, and then you'll see right above the sign button is that sine minus 1. You're going to do shift sine instead of pressing sine. So type your decimal in first and then shift sine. For this calculator, you'll do shift, again, shift, sine, and then you will put your 0.5 in. So depends on whether you have your frontwards calculator or your backwards calculator, and you should find that the angle is equal to 35 degrees. Same thing with cosine. Our angle is equal to, when we want to find out what the angle is, we often use theta. That's just a Greek letter to represent the angle. Some things are so intuitive to me, I forget to mention it. So theta is just our angle. So we're going to use inverse cos, so cos minus 1 of 0.7071, and that will give you 45 degrees. And then if you do the same thing with tan, our angle is tan minus 1 of 1.0451, and that gives us an angle equal to 46 degrees. Now, we won't use this particular method very much in this lesson, but you will use it in the second lesson that follows this. Now that you can use your calculator, I want to stop and think about our ratios before we decide to use them. This gives you some tools for error checking. My question is, what possible values could the ratios have? So I want you to think about, could the ratio be greater than 1, less than 1, or anything? Okay, so sine ratio. The sine ratio, so the sine of an angle, is equal to the opposite side divided by the hypotenuse. We know the hypotenuse is always the longest side. So if the number in the numerator is smaller than the number in the denominator, this will always be less than 1. So if you are ever trying to find an angle and you have your opposite and hypotenuse bigger than 1, you know you've made a mistake. Maybe you've accidentally labeled your sides wrong. Your calculator will tell you you have an error if you put a ratio larger than 1 in and you use that shift sign function. Cosine function, well, the cosine of an angle, CAH, is equal to the adjacent side divided by the hypotenuse. The hypotenuse is still the longest side. A will always be smaller, so this one's going to be less than 1 as well. So if your calculator tells you there's an error, double check your ratio. You might have something flipped incorrectly. And then the tan ratio. Tan of an angle is equal to opposite divided by adjacent. Now, there's no rule that says one of these has to be larger than the other, so it can be anything. Tan will never give you an error. It doesn't mean you're not wrong. The calculator just won't pick it up for you. So that's a really good little piece to remember just as you're going through your calculations. Sometimes people will have to be calculating something. It's just a finger slip and your calculator will give an error. If the calculator tells you you have an error when you're using sine or cosine, the odds are you've made the error and not the calculator. You've made an error putting something in. All right, now we're into some calculations. I want to know which ratio is required to solve each of the following problems. We don't need to calculate these ones. I just want to know what ratio will you use. So the first thing I often do on my page is I'll write SOHCAHTOA, S-O-H-C-A-H-T-O-A. This is just my list so that I can keep track of things. It's one of the first things I write down when I'm doing a test, or even if I'm working on an assignment. I have a tendency to flip numbers around. So I'll write it down just so that I don't accidentally flip something. It keeps errors from showing up. You guys know every now and then an error will come through, and I'll always cross-check. If somebody's answer comes back as wrong, I'll often double check, especially if there's a couple answers come back incorrect. I'll start to question, oh, is there something that's gotten flipped? Because I know that's a weakness that I have. So this particular triangle, we want to figure out which ratio do we need. In order to do that, we need to label our sides. So this 28-degree angle is our subject angle. If we go directly across from it, we hit X. That must mean this is the opposite side. Next to it, we have the adjacent side. And then over here, oops, we have our hypotenuse. Okay, we want to know which ratio do I use? Well, I know a number for the hypotenuse, and I want to find out X. So I know H, I want X, which is also the opposite, which ratio uses O and H. So if we look through, the only ratio that uses O and H is sine. So for this one, I would use sine. Okay. You don't have to calculate it. You could go through and calculate if you like. You don't have to calculate. The next one, which ratio are we going to use? So do the same thing, label your sides. There's our hypotenuse. 40 degrees is the angle that we're discussing. X is again opposite, and 15 is adjacent. We have opposite and adjacent. The only one that uses that is tan. So just simple process of elimination to check which angles you happen to need. Pretty straightforward. I'm going to do 3 math examples with you. I'm going to do an example of each type of question, and then I'm going to give you some practice to work at on your own, as well as a little quiz just to be able to let you do a quick check to make sure that, yes, you do know how to calculate. You can put things in your calculator correctly. So this one says, calculate the length of the side mark X in this triangle. So the first thing we want to do is label our sides. So we have hypotenuse, opposite, and adjacent. Which ratio will I need? Well, I have hypotenuse and opposite. Hypotenuse and opposite is the sine ratio. So the sine of our angle is equal to opposite over the hypotenuse. Fill in the values that you know. So we know the sine of 40 is equal to, the opposite side is X divided by 8. Now we're into rearranging. That algebra we did last semester is going to come back a little bit. So in order to get rid of the 8 on the bottom, we're going to multiply both sides by 8. They cancel out, and we have x is equal to 8 times the sine of 40. If you put that in your calculator correctly, and your calculator's in degree mode, you should get 5.14 or approximately 5 centimeters. Okay. Take a minute, plug it in, and make sure you're getting the right values. It's easier to do it now than it is to check it after you've done the quiz. If you're not getting that answer, before you keep going through, check the next example if you want, but before you keep going, shoot me a text, send me an email, let me know you're not getting it, and I'll go through it with you, and we'll make sure that you're not having a calculator issue. Example 3, calculate the length of side AB. So side AB just means the connection point between A and B. That's a common way to label sides in a triangle. So we don't know what's the length of this side. I can't use Pythagorean theorem because we only know the length of one side. We have to use our right angle trigonometry. So let's label them. 50 degrees is here. This is my hypotenuse. This is my opposite and adjacent. I have adjacent and opposite. Which ratio do we use? Can't be sine or cosine because they both use the hypotenuse. We have to use tan. Personally, I think we use tan the most in the trades. And that's because we often know, if you think of it like rise and run, we often know rise and run, but we won't know, let's say, raptor length. So tan is the one that I think we use the most in terms of traits. And now we just plug our values in. So the tan of 50 degrees is equal to the opposite side of x over 9. Again, multiply both sides by 9. 9 times the tan of 50 equals x, which means x is equal to 10.8, which is approximately equal to 11 centimeters. You could leave it to 1 decimal. It didn't say where to round to for decimals. There's no decimals here, so I would just round it off to a whole number. That's why I put the little squiggly marks that say approximately equal to. It's not perfectly equal to, but it's close. All right, one last example for you. Now, this is the example that people tend to make the most mistakes on, but you are really good at doing algebra. You did good in your algebra last semester. So I'm hoping you can do this question as well. I'm going to give you some tips. This particular math is going to show up again. It's the one that people get stuck on. So I want to know the length of the hypotenuse. So first we got to find the hypotenuse. There it is. This side is next to 20, so it is adjacent. We don't really care about the opposite side, so if you don't label it, that's okay. We're not interested in it. We want H, we have A. Cosine is the only ratio that will give us that. So the cosine of an angle is equal to adjacent divided by the hypotenuse. So the cosine of 20 is equal to the adjacent side, which is 12, over the hypotenuse. And I want to figure out, well, how big is the hypotenuse? Now, the key thing here is we have H on the bottom. You cannot divide to get rid of H. I'm going to take you in the long way, and then I'm going to give you the shortcut. We need to get rid of the fraction first. Multiply both sides by H. Now we have H times the cosine of 20 equals 12. Cosine and 20, they stay stuck together. You can't separate them. Not unless you do that little inverse cos thing. So cosine and 20 stay stuck together, so we're going to move them together. We're going to divide both sides by the cosine of 20. And we get, these cancel, the hypotenuse is equal to 12 over cosine, 20. That's supposed to be a C. Now, if you look here, we started out with, this is what we started with, the box around. This is what we started with. Look at the position of the H and the cos 20. They switched places. You can use that shortcut as long as you understand the math that goes in between it. So anytime you're solving for a letter that's on the bottom of a fraction, you can trade places with what's on the other side of the fraction, as long as it's not as long as on the other side of the equal sign, as long as it's not a fraction as well. Then you have to use your ratio math. Okay, if you're not sure about that, check in with me. I'm happy to go through it with you and just give you a little update. So now we can plug those numbers in. H divided, you type in your calculator 12 divided by the cosine of 20, and you will find your hypotenuse is equal to 12.8 or approximately 13 centimeters. This is the trickiest question to do when you're solving for the hypotenuse, just because you have to do the division. All right, so that finishes off our examples. Not a whole lot of examples, but there's a great practice sheet for you to work through that has some solutions. So how do you pick the ratio? That's one of the biggest questions that I usually get. Once people have the ratio, they're usually good with solving it. So to pick the ratio, you want to find the ratio that has the side you want and the side you have. So you've got sine, cosine, and tangent. To pick it, use process of elimination. If you have opposite and adjacent, you're going to use tangent. If you have hypotenuse, you're going to use either cosine or sine. But find the ratio that has the side you want and the side that you have when you know what the angle is. That's a good little tip. And just if you need to, write down SOHCAHTOA and check off the pieces, and that will help you out. You always have to have 2 out of the 3. All right. If you have any questions at all, let me know.